Hello good people, I'm going to spend some time exploring the Arrhenius definition of acids and bases. According to Svante Arrhenius, in an aqueous solution, acids will increase the concentration of hydrogen ions, while bases will increase the concentration of hydroxide ions. If we look at hydrochloric acid, in an aqueous solution it will dissociate to give hydrogen ions and chloride ions. By the same token, nitric acid will dissociate completely to give hydrogen ions and nitrate ions. The key thing to note here is that no matter the acid we introduce, we are always increasing the concentration of hydrogen ions. That is what causes the acidity. What about bases? The quintessential example of a base is sodium hydroxide. In an aqueous solution, it will completely dissociate to give the sodium ion and the hydroxide ion. If we look at another base, say calcium hydroxide, we will end up with a similar thing. Calcium hydroxide will dissociate completely to give calcium ions and hydroxide ions. As a bit of a side note and a stoichiometry reminder, note that a mole of calcium hydroxides will produce 1 mole of calcium ions and 2 moles of hydroxide ions. The Arrhenius definition of acids and bases is very good and straightforward. If a compound is a source of hydrogen ions, it is an acid. If it is a source of hydroxide ions, it is a base. However, this definition has a bit of a problem. And that problem is ammonia. In aqueous solution, ammonia is a base, and it generates hydroxide ions. However, the question that the Arrhenius definition cannot answer so easily is, where does the hydroxide come from? This is where we need to turn to the Bronsted-Lowry model. I will leave that for another video. That is all for now, and I will see you on the flip side.